I'm Shahani. I'm a professor of materials science and engineering here at the University of Michigan. My research focus is on metals and alloys, which are all around you, from bicycles to space frames to jet engine turbine blades. And generally, we prefer metals in their solid state, which necessitates cooling a high temperature liquid. And these solid metals have microstructures. And by microstructure, I mean the way that the phases are arranged in space, their orientations, their shapes, their length scales. Microstructure is the essential fingerprint of a material, and it is my goal to understand the origin of this microstructure and how we can control it to meet technological demands.
A lot of technologically important tools and parts and materials are made using complex transformation pathways. And these have to be studied and well understood in order for us to engineer better materials that are going to be very important for our future.
To understand solidification and more broadly processing of materials, we leverage state-of-the-art characterization approaches, namely 3D imaging techniques at both the synchrotron as well as our own lab. And we use these techniques to obtain a holistic perspective on the microstructures and to understand where this microstructure comes from in 3D space and in time. The three-dimensional data that we obtain can be used to validate and refine theories that are actually in textbooks. And that's the power that we have as experimentalists. We can image pathways that are only talked about at a very theoretical level.
So right behind me, we actually have the Xtradia VASA 520. It is a laboratory-based X-ray microscope produced by Zeiss. This is a very powerful 3D imaging tool that can probe the internal structure of materials down to 700 nanometers of spatial resolution in 3 dimensions.
I derive great pleasure from mentoring students, and particularly undergraduate students. In fact, in my group, we have a track record of success in advising undergraduates in research. In fact, 3 undergraduates have published first author papers in peer-reviewed reputable journals in material science. And I think that the next could be yours.
During my time in Professor Shahani's lab, I had the good fortune to be able to contribute enough that I was able to write a co-authorship with one of the graduate students on his last paper for his thesis, where he was looking at specifically the percolation of the grain boundaries, and then where my contribution came in is I dived more deeply into the triple junctions of this experimental samples that they took X-ray tomography of.
For the graduate students, if you are passionate about microstructure control in manufacturing, whether that's near equilibrium or far from equilibrium, such as in emerging technologies like additive manufacturing, please talk to me.
My research had a dual nature of both experimental work, but also a lot of data synthesis and data analysis work on the computer to visualize the data we got and to unpack it and to unearth the different mechanisms at play that we were able to visualize in real time.
I'm always excited to meet new people, new faces, and to work with them to solve some of these problems that we face in the community.